Okay, so this is going to be test 1C. It's going to continue using the kinematics equations from test 1B, but we're going to apply it to falling objects that are falling. That's it. So you won't learn any new equations, how to use any new equations. Okay, so this test is not just going to be problem solving, it's also going to have concepts that you need to understand. And the formative quiz will practice both the concepts and the problems. Okay, so let's start this. Free fall. Free fall is very specifically defined. Let's see where I did that. It's probably the next page. Well, I don't know if I did it. Free fall occurs whenever an object is dropped near a planet, something very massive. It could be a star, it could be a moon, it could be an asteroid. But whenever an object is dropped above the surface of the massive object, and the only force acting on the object is its weight. So it's when an object's falling, with the only force acting on the object being its weight. So if the only force acting on an object is its weight, it's in free fall. Okay, now you might say, well, Mr. Noyes, I'm sitting in my chair right here, and the only force acting on me is my weight, so why am I not in free fall? Okay, so here's you in your desk. Okay, but and of course there is a weight. Your weight is the force of gravity pulling down on you. I'll give that a little W for your weight. It's the force of gravity pulling on you. We'll talk about it in a whole nother chapter. But you also have the force of the chair pushing up against you. And if your feet are on the ground, the force of the ground pushing up against your feet. Okay, so the force, there's several forces acting on you as you sit in that chair. Not just one. If there's more than one force besides weight acting on you, you're not in free fall. So think of a baseball then dropping. Okay, if there's the only force acting on it is the baseball's weight, then it's in free fall. If it's resting on the ground's pushing up against it, and it's not in free fall. It's weight and the ground pushing up against it causes it not to be in free fall. Okay, so where the ball was falling and there's a little bit of air drag on it, a little bit of what we call air drag, then it's not in free fall. It could be falling, but it's not freely falling. So free fall. Free fall means the only force acting on you, on the object, is the weight of the object. All objects fall towards Earth with the same acceleration if you don't have drag as a factor. So what kind of device can take all the air drag away from a falling object? Okay, so what kind of object can fall freely without any air drag? Well, if it's really aerodynamic and dense, it will fall with very little air drag. We say air drag is negligible, or air resistance is negligible, but we can make it so that any object, regardless of its aerodynamic shape or lack thereof, or its density, any object will fall without drag. What kind of place would it be if there was no air drag? Well, a place where there's no air. Okay, so we can suck out the air of a container and make it a vacuum. A vacuum is just a place where most of the air has been sucked out of the chamber by a vacuum pump, and what's left is just a few air molecules that won't cause any air drag whatsoever when an object's moving through is falling. Now, it's important that you understand a vacuum does not turn off the gravity. A vacuum does not take your weight away. It just takes the air drag that is slowing you down as you fall away. Okay. Okay, so all objects will fall towards the earth. They'll accelerate because the only force acting on them is their weight. And we call that acceleration that any object has, regardless of mass or shape or density. We call that acceleration a falling object has to be the acceleration due to gravity. Some people call it gravity. It's not gravity, it's the acceleration due to gravity. And all objects will fall at, if you're near Earth's surface, at 10 meters per second squared. It's really 9.81 if you want to be really picky, but I have my test questions set up to have little g to be 10 meters per second squared near Earth. So, what if I ask you, who in a vacuum, what would fall quicker from the same height? A feather or rock? Would a feather or a rock fall from a given height at a quicker rate? In other words, who would hit the ground from the same height? When dropped from the same height, who would hit the ground first? A feather or a rock? Okay, well, if it was in the air, if there was air resistance or drag, of course, the rock would fall with an acceleration close to 10 meters per second squared. But the feather would just take a long time to float down to the earth, because air drag's a bigger factor on low density, high surface area objects such as a feather. Okay, but in a vacuum, if both were dropped from the same height in a vacuum, who would hit the ground first? A feather or a rock? Well, I'll show you a video in class where not obviously, the feather and rock hit the ground at the same exact time when dropped in a vacuum from the same height. It's really weird to see that, I'll show you. There's also a video, you can check it on YouTube, of when the astronauts first visited the moon, did the moonwalk, and one of the guys dropped a hammer and a feather, and both hit the ground of the moon at the same time when released at the same height. That's because the moon has basically no atmosphere. The moon's not massive enough to have kept any atmosphere it may have had in the past. So there's no air drag, so the feather and the hammer hit the ground at the same time when released from the same height over moon's surface. Okay. Okay, let's talk about what if I threw something up and let it fall back down. Okay, so important thing is when here's a rock and I'm throwing it and it's coming off my hand and it's rising, and here it hits the top, and for a moment it has to stop. Okay, because it has to turn around. You cannot change your direction. Let's say you're driving your car forward and then you want to go in reverse. You can't just, let's say you're going 5 miles per hour and you had to stop first, and then you had to slow down, stop, and then you had to put in reverse, and then you can pick up speed in reverse. Okay, so what happens at the top when you throw a rock and it reaches its highest point? And the V at that point would have to equal 0. It has to stop before it turns around. Okay, and on the way down, of course, it picks up speed from the top. Okay, so what happens to the top? V equals 0 meters per second. What's the acceleration at the top? Well, here's the trick. The acceleration everywhere along, going up and descending, going down, the acceleration is the same. So it's negative 10 meters per second squared on the way up, not positive 10, it's negative 10. And on the way down, it's negative 10 meters per second squared as well. Now, that might not seem correct to you. Then at the very highest point, it's negative 10 meters per second squared. So if Earth is the object attracting the dropped object, the acceleration is going to be, as long as weight is the only thing acting on it, only force acting on it, as long as weight is the only force acting on it, the G is in free fall, whether it's going up, whether it's stopped at the top for a moment, whether it's falling downwards. Okay, so that is something that people have to get over and learn. I'm not saying that gravity is negative 10. I'm saying the acceleration that the object experiences is negative 10 meters per second squared. Now, how's that so? Well, on the way up, as it goes up, you can see that the velocity is in what direction? Upward, so it's positive. And we obviously see that the speed is decreasing, is slowing down. So if something's slowing down, the velocity and acceleration have to be in opposite directions, right? We learned that in the last chapter. Okay, how about on the way down? Is the velocity is obviously negative on the way down. It's falling downwards. And the speed is increasing, obviously, because it was stopped up here, and now it's picking up speed again as it falls. So if the speed is increasing, I should put an S for speed. If the speed is increasing, the signs have to be the same. Signs of the velocity and the acceleration have to be the same, and they are. So that's why acceleration is always negative for a falling object or a rising object. Now, acceleration is not negative 10 if I'm throwing the ball upwards. I'm applying a force on it. I'm applying a force from my hand on it as I throw it upwards, and so it's not in free fall. So the acceleration would be something other than negative 10. Actually, it would be positive because the force and acceleration are always in the same direction. But that's when my hand's in contact with it. And same for when I'm slowing it down, when I catch it. So, okay, also one thing, this looks like a parabola. Okay, but I'm not talking, I just drew it like that to, so it be not all compressed in my diagram and confusing. So I isolated the trip going up and trip going down. We will do parabolic projectiles in the unit after next. Okay. We didn't talk about position versus time and distance versus time, acceleration versus time graphs yet. So we'll skip that, maybe come back to that later. But let's talk about acceleration a little bit. So positive physics does a really good job at this. Now this picture right here shows where the ball would be 1/10 of a second. Look, 1/10 of a second later. After it takes a little picture every 10th of a second, and shows where the ball is at that 10th of a second. And this is kind of easy to do. You're in a dark room. Okay, you drop the ball. There's a strobe light flashing 10 times in 1 second. So every flash is a 10th of a second. And you click your iPhone camera, and it keeps the shutter open, and every 10th of a second when the flash goes on, it picks up that image, and then it puts it all in one picture, like the picture that I circled in blue there. So look, we know what the speed is. So let's just say a few things. The distance, there's second 0. Then 1/10 of a second later, they're going to put a negative. Why? They're using Y. Really, they should have said change it Y. That's the vertical displacement. And it's going to be negative. It's going to be negative. And you can see that this is at 0.0. This is at 0.1 seconds. You can see that's delta Y1. This would be, okay. Hello? Okay, this column is VF. Now VO is going to be 0 because I dropped it I didn't throw it, I dropped it. So in all these cases, VO is 0. Okay, so This would be VF, the second column, and their negative velocity is going downwards, so they have negative signs on them all. And this is the time from the drop time. So this is just plain old t in seconds. Now we can solve for all this using the kinematics equations, and we will pretty soon. But notice for now that how the distance keeps on increasing between the two every tenth of a second. So as the ball falls, this distance between the current time and the previous time gets bigger and bigger and bigger. The distance gets bigger. Well, so we'll solve all this using kinematics equations later, but I could plot all that and get these position versus time graphs or velocity versus time graph. Okay, but we won't talk about the graphs yet. But you should understand what that picture is right there. Not the graphs, the hand. Okay, once again, I'm not doing graphs yet. Okay, let's do some of these. A ball is dropped from rest and falls. What is true about its motion? Okay, so VO is 0. Falls. Do not consider, neglect air resistance or drag. So there's no drag. What is true about its motion? Acceleration is constant? Yes. A is equal to G is equal to negative 10 on Earth meters per second squared. No. Speed would be increasing, but acceleration isn't. No, speed is increasing, okay? Because it's falling downwards. Now, acceleration would be decreasing if there's drag. A ping pong ball, very low density, high surface area. A ping pong ball will start dropping with an acceleration of 10 meters per second squared downwards, but then it will gradually decreases acceleration until there's zero acceleration and the ball's falling with constant speed if it's dropped from a high enough height. So if there's drag, the acceleration is decreasing, and it will decrease to zero and at that point the ball will be falling with constant velocity until it hits the ground. So this one's correct. B is correct if there's air drag, but it says there is no air drag. So do not consider air resistance, so it's not B, letter A. Okay, acorn falls from an oak tree. Okay, so these are really easy. If it falls from the oak tree, that means VO is 0. 2.5 seconds is the time. How fast was it going when it hit the ground? Okay, a lot of people at first say that's VF. A lot of people at first say, well, it's 0, it hits the ground and stops. I'm not talking about when it after it hits the ground. I'm talking about the point when it's no other force on it except weight and it's falling freely. So how fast was it going when it hit the ground? VF. So you might say, oh, you don't give me enough information, but I do. A is equal to G is equal to negative 10 meters per second squared. Well, they're going to use 9.8 in these problems, but I'll just round up. Okay, so pick an equation. Well, a simple one of the 5 equations. A equals VF minus VO over T. So, -10 equals VF minus 0 because it dropped from rest, started from rest, over 2.5 seconds. Okay, I'm going to cross multiply, and get 25. -25 equals VF. And that looks like right here. Okay, the velocity is -25, but the speed is 25. Okay? Okay, now the ball is thrown down off a bridge, so VO is not equal to 0. It's something else. It's VO is 5 meters per second, but don't put 5. It's -5 meters per second because it is thrown downwards. What is the velocity 2 seconds later? So what's VF? That's my unknown 2 seconds later. So that's the time. So again, A equals VF. You might say, I can't do this. Well, you can if you know that A is 10 meters per second squared if we're talking about Earth. So A equals VF minus V over T. -10 equals unknown minus a -5 over T, 2 seconds. So cross multiply -20 equals VF plus 5. So VF is equal to -25. Now you could do this positive physics meters per second. So they're using 9.8. So that's what closest answer is. I'll have my answers using 10 when I give you a formative quiz or test. Positive physics approaches this problem in a very intuitive, easy way. So let's show the way they do it. So they kind of make a little table. And here's the time. And here's the speed. Oh, actually velocity. So at time 0, when it came off his hand, it was going -5. Okay, at time 1 second, it's going 10 meters per second faster every second. So, because A equals -10 meters per second squared, so it picks up -10 meters per second every second. So, in the first second of falling, -5 plus -10 is -15. And then in the second of falling, that's where we're ending, -15, it falls another, it attains another 10 meters per second downward. So that'd be -25 meters per second. They solved it without even using a kinematics equation, just using common sense. Okay, you can do it that way. Okay, an arrow is fired into the air, so VO is not 0. Has some speed once it comes off the bowstring. It reaches its highest point 3 seconds later. What was the VF? Okay, so this is the time to get to the top. And at the top, you gotta realize something. What's the speed at the top? Let's call it VF. It's 0, because you have to stop and turn around. Okay, so we got, and then don't forget A is equal to G is negative 10. Okay, so now you could do that positive physics method, which I can do that right now if you want. But we can also do an equation. Okay, so I'm looking for VF. Okay, so A equals VF. Oh, no. VF is 0. I'm looking for VO. So I use a simple acceleration equation. So acceleration is negative 10 equals VF 0 minus VO over 3 seconds it took to get to the top. So VO, negative VO equals negative 30. So VO equals positive 30 meters per second. Now, you could have set up the positive physics way of doing it, the time and the velocity. So at time 0, the velocity was unknown. 1, what they say, 3 seconds. So at 3 seconds, I know it was 0. So it's going up. The speed's decreasing as I go, but it's decreasing by 10 every second. So this had to be 10, 20, and this had to be 30. Okay, so, you can do it a super easy way and not go through all the equations. Okay, so here we have the distance that falls, delta x. What is his final speed? Okay, VF is question mark. A drop ball, that means VO is 0. And I know A equals G equals negative 10. So what's an equation with X, VO, VF, and A? Look at your 5 equations. How about this one? VS squared equals VO squared. There's no time, so that's why I picked this one. So, drop. So this is what I'm solving for. Final speed equals 0. That makes VO is 0, so that crosses it out. 2 times negative 10 times. Now displacement is drop from here to there. It has to be negative displacement. So they told me negative 8 meters, but I won't tell you that. You got to figure that out. So VF squared is equal to 20 times 8 is 160. Okay, so VF is equal to square root of 160. Okay, I gotta take my calculator out. I get 12.649. So 12.6 meters per second. Now, actually, that's negative because square root, when you square root something, it could be plus or minus. The solution could be plus or minus, but that's not a big deal because he said, what is his final speed? Didn't ask for his final velocity. So the closest answer I got is this, but why is it not exact? Because they're using 9.8 instead of 10. Okay, now I can't really do a shortcut on that like I did on the others. A ball is thrown upward with initial velocity. Okay, so VO equals positive 25 because it's going up. How high does it go? So delta X, before it comes to a momentary stop at the top, VF is 0. So again, now you could do this several ways. I also know that A is equal to negative 10, acceleration due to gravity, Don't forget that. In all these problems, that's going to be true unless we're on another planet. So what equation has VF, VO, delta X, and A? There's no T, though. There's no T. Okay, so how about this one? VF squared equals VO squared plus 2A delta X. So this is 0 equals, because VF, it stopped at the top, 25 squared plus 2 times negative 10 times delta X. Again, I can't take a shortcut like we did in the first few problems. Okay, so let's figure this out. So negative 20 delta X, 25 squared. So let's get 20 delta X to the other side. Add 20 delta X to both sides, so I get rid of that negative. And so delta X equals 25 squared over 20. 25 squared divided by 20 is equal to 31.25 meters, which looks like the closest answer is that one. Now look, because I'm using 10, I'm going to get some error, but for short trips it doesn't matter. Okay, the bigger, the faster, how can I say this? The further distance it falls or rises, the more inaccurate it will be. So in labs, we'll probably want to use negative 10, but if we're outside shooting it really high, we use negative 9.81 for the A instead of negative 10. Okay, so let's go on. Next problem. This is a little trickier. They should have been more obvious about it. Okay, so an arrow is projected upwards with a velocity of 40 meters per second. So that's positive 40 original velocity. It reaches a target in 3 seconds. How high is the target located? So I'm looking for delta Y. I'll continue to call it delta X, okay? Now the trick here is we can't assume the target is at the highest point. So I don't know what, if the target was at the highest point, the VF equals 0, but I don't know what that is at this point. If I can find it. So I know A is G, negative 10 meters per second squared. Okay, anyway, let's find out what VF is using the acceleration equation. So negative 10 equals VF, which we can't assume is 0, minus positive 40 over 3 seconds. So let's cross multiply. Negative 30 equals VF minus 40. So VF equals 40 minus 30 is equal to 10 meters per second. So I guess if you're shooting a bird or something, a duck or something, the arrow hits the bird going 10 meters per second upwards. The bird wasn't at the highest point of the path of the arrow, or else VF would be 0. Okay, now I can do this. I can do the rest. find delta x, really delta y. Okay, VOT plus AT squared over 2. Oh shoot, I could have done that before. Crud. Okay, so I'll do that in a moment. That would be a shorter cut way of doing it. I'll save that. Okay, but let's continue my train of thought. Again, there's multiple ways to do these. I just picked a trickier way because I don't want you to accidentally do it this way with VF equals 0, because you would have gotten a totally different answer. Okay, so I'm going to go VF squared equals VO squared plus 2A delta x. So 10 squared equals 40 squared plus 2 times negative 10 times delta x. So 100 minus 1600 divided by negative 20 equals delta x. So what does that come out to be? 1500 divided by 20. Negative 1500 divided by negative 20 is equal to 75. So that would be this answer. Now, if I had done this way, the simpler way, which I didn't think of at first, we should get the same answer. Okay, VO is 40 times 3, right? Yep. Plus negative 10 times 3 squared over 2. That would have been much simpler. Equals 120 minus 5 times 9. 5 times 9 is 45. 120 minus 45 comes out to be 75. So this would have been the easier way to do it. You wouldn't have found VF, but the reason I did it the other way was I just did a problem where very similar to that, except that VF was 0 because that was the highest point of the trajectory, right there at the highest point. Okay, so I would pick the easier way if I were you guys. Okay, so this next one, how tall is the building? So I'm looking for delta y. I'll call it delta x because it's really delta y, but I'm not pick at it. Okay, A equals negative 10. We're on Earth. He drops this, so VO is 0. Time is 2.6 seconds. Okay, so can we use that simple equation we just did? Yeah. VOT plus AT squared over 2. So we're looking for delta x. Delta x equals VO is 0, so that knocks that out. Negative 10 is A. And then T is 2.6 squared over 2. So 5 times 2.6 squared. 5 times 2.6 squared is 33.8. Actually negative 33.8 because it's from the from the start to the finish, going downwards, 33.8 meters. That's the displacement. So the height is, you don't have a negative when you talk about scalars like height. Okay. Okay, hopper is a little springy thing. So these are all kind of easy ones now. Okay, flips a hopper. So he it's like compressing it, and you sit it here, and then it pops and it jumps up like a grasshopper. Okay, so VO is you might want to say it's 0 because it's at rest. Yeah, it is, but what's the speed it has when it leaves the tabletop, just like the basketball player. So VO is not equal to 0, even though it's at rest until it pops. But I want the speed in the air the moment it comes off the table. So that's what I'm looking for. VO is what? A, once it's in the air, not the elastic force applied to it. A is negative 10 again. The delta Y or delta X is positive 1.4. Maximum height, so VF is 0. Okay, so let's see. You can just use, let's change that. VF squared equals VF, because I don't have time. We use the other one. So 0 is equal to VO squared. That's what I'm looking for. Plus 2 times negative 10 times delta X. Okay, so delta X is 1.4. So 1.4. So VO squared equals, I'm going to put this on the other side because it's negative, add it to both sides, equals 20 times 1.4. So VO is 2.28. Square root of 28, right? 2.8 times 10. And the square root of 28 is 5.3. So it pops off the ground with a speed of positive 5.3 meters per second. Okay, this is an important problem. Okay, so this could be a ball that you kick upwards. It doesn't have to be a rocket. Okay, so the total time is 3.2 seconds. The time it takes to go to the top and back to the bottom. So that's very important that you realize that's not just the time it takes to get to the top. What is the initial velocity? Again, you might say, well, Mr. Noyes, the rocket was at rest at the beginning. No, it was, but I'm considering its flight. So VO is the fastest speed it had off the launch pad, or your foot if it's a football that you're kicking, or a soccer ball. Okay, so the VO is question mark. I'm going to do a little trick here. I know that the VF at the top is 0 at the top. So that's a little trick I do. And so the time to get to the top is half the total time if it lands in the same place that it started from, same level. So time at the top equals the total time divided by 2 because it's symmetrical. Okay, so that'd be 1.6, right? No, 1.5 plus 0.1. Yeah, 1.6. Okay, so now it's easy. Acceleration equals Vf minus Vo over T. -10 acceleration due to gravity equals 0 minus Vo, which I'm looking for, over 1.6. So cross multiply, so I get -16 equals 0 minus Vo. So Vo equals 16 meters per second. So very important kind of problem. Okay, what's this? Ooh. I'm trying to show you here. Okay. So, yeah. What I'm trying to show you here is that right here, if you throw it up and it's symmetrical, I mean, it's going to, here's the ball that way, here's the ball off his hand, it's going 13 meters a second. Right here, it'd be going -13 meters a second, the same speed, but downwards. Okay, so, I mean, if you have a problem that looks like that, like a horse, like a bishop's crook, shepherd's crook, what you can do is disregard this whole top part. This whole top part, disregard. And just take it from there to wherever you're going to go down here. Okay? So that's kind of brief, vague, but okay. So okay, that's enough of that. Okay, so two-step problems. Yuck. I know I'm doing this because on positive physics they have one like this. A small rocket with a booster blasts off and heads straight up when at a height of 5 kilometers. Okay. Okay, so this will be, what is the maximum height the booster attains? Okay, here's the booster. This part right here is the booster. So the booster had a speed of 200 meters per second when it was released. So did the rocket, but it was part of the rocket. So the VO of the booster is 200. What is the velocity of the booster at a height of 6 kilometers? Okay, so I'm looking for VF. Of course, A would equal -10 as usual. Okay, now, so how high did it go from the point that it had 200 meters per second? Well, it was at 500 kilometers when it was released, and then it goes to 6 kilometers. So delta x, the position it traveled from 5 to 6 is 1 kilometer. So it was 5 and it rose to 6. So really, the distance of the trip that it traveled, delta x, is 1 kilometers upwards. And I don't like kilometers. I got to change that to meters. And a kilo means 1,000. Okay. So that's positive 5. Wait, sorry. 2. We don't even need that. Okay, so we're looking for VF. We can always neglect air resistance. So VF is question mark. So I don't have time, so I'm going to have to use that equation, VF squared. VO squared plus 2, 8 delta x. This is not a two-step problem. I don't know why I said this is a two-step problem. So VO squared is 200 squared. It's meters per second, so I don't have to convert that. 2 times -10 because it's not, there's no other force acting on the booster when it's released except its weight. And then 1 kilometer, 1,000 meters. So 200 squared minus 20,000 is equal to 20,000. And so VF squared, so the square root of 20,000 is 1.77. Oops. Square root of 20,000 is equal to 141 meters per second, which is still really fast. Okay, so it's going to keep on going and going until it slows down to 0, rising with no rocket power, right? With no rocket power like the rocket has. Then it will fall back to Earth. Okay. Let's do some J-type problems like I was talking about. Okay, here we have VO equals 4, positive 4 because it's going upwards. Distance between his feet off board and water is 1.8 as is shown. So really delta y or delta x is negative 1.8. What is his highest point above the board? So, okay, that's another delta x. So let's call that delta x2. That's what I'm looking for. Okay, well, we know at the top, we'll call that VF. Okay, so let's call it VF is 0 at the very top. G is A is negative 10. Okay, so VO is still 4. So again, it looks like we'll keep on using the same thing. VO squared plus 2AX. Okay, so this is 0 equals 4 squared plus 2 times negative 10 times delta x. That's what I'm looking for. So get the 20 delta x on one side. So add 20 delta x to both sides. Equals 16. So delta x equals 16 over 20. 0.8, 4/5, which is 0.6. So he only got 0.6 meters off the board. Wait, did I do that right? 16 divided by 20. That's 0.8, sorry. You got 0.8 off the board. 0.80 meters off the board. What speed does his feet have right before contacting the water? Okay, so that'd be VF. Let's call that VF2. So we can take it from the start. If we take it from the start, let's do a different color. We take it from the start. Okay. Okay, this is VF2. Okay, so VF2, we know delta X is negative 1.8. It's that one. If we're going from the start to the finish. Okay. VO is the speed off the board, which is 4, positive 4. And A is still going to be negative 10. Now, a lot of people say, well, what about all this stuff up here? You don't have to worry about it. So here's your VO, here's your VF, here's your displacement in this problem. And so all we do is find VF. Same equation, different terms. So VF squared equals VO squared plus 2A delta X. Okay, so let's plug in 4 squared plus 2 times negative 10. Delta X is negative 1.8 equals VF squared. So VF squared equals 16 plus 20 times 1.8. 16 plus 20 times 1.8. I'm going to get 52. So VF is the square root of 52, which equals 7.2. So he's going to hit the water. His feet are going to hit the water with a speed of 7.2 meters a second. What's the total air time of his feet? Okay. So, I mean, you don't have to make this tricky. A equals VF minus VO over T, right? Negative 10 equals VF, I just found, 7.2, minus VO is 4 over the time. Okay, be careful, because right here, this is negative 7.2, right? The speed is 7.2 when it hits the water, but the velocity is really negative 7.2 because it's going downwards. Velocity is a vector, or else you get a positive number and you'll figure it out. So negative 10t equals negative 7.2 minus 4. That's a big difference. I mean, if you have forgotten a negative, that's a big mistake. So t equals negative 11.2 over negative 10. So 11.2 divided by 10, the negatives cancel out, equals 1.12. Why did I use my calculator? So 1.12 seconds to take that dive from when his feet leaves the diving board to when his feet hit the water. J problem. Okay, one more, I think. No, we got a few more. A golf ball shot up from the top of a 60-meter high building. Okay, and hits the balcony on the way down 30 meters above the release point. Okay, this is all shown in the picture. Speed of 20. Okay, so we know that the VF is negative 20 meters per second. Okay, and what was the original speed of the golf ball? Okay, so that's VO. Off the hand, 30 meters below the balcony. So that's what I'm looking for. I don't know what VF is. I know that delta X is positive 30 from here to there meters. I know A is negative 10. And I know VF is negative 20. So here we go again with that same equation. Delta X, actually delta Y, but who cares, equals, no, I don't want that one, because I don't have time. Okay, so how about VF squared equals VO squared plus 2A delta X. So negative 20 squared equals VO squared plus 2 times negative 10 acceleration due to gravity times positive 30. Okay, so let's clean this up. VO squared equals negative 20 squared. Then get this over the other side by subtracting from both sides, subtract the negative. So I'm going to add it to the other side. So that'd be 20 times 30. 2 times 10 is 20 times 30. Why is the negative? I added that to both sides, 20 times 30, and it cancels it out right here. Okay, so what we have is, so I get VO equals 400. This makes it positive. Negative 20 times negative 20 is 400 plus 20 times 600. And then I have to take the square root of it, right? Actually, that comes out 400 plus 600, that comes out 1,000. Square root of 1,000 is 31.6 meters per second. What was the air time for the ball? Okay, so the total time. Well, no, that's okay. That's the easy thing. So A equals VF minus VO over T. Negative 10 equals VF, which is negative 20. VO, we just found 31.6 over time. So cross multiply. 10t equals 51.6, negative 51.6. Actually, negative 10t equals negative 51.6. So t equals negative 51.6 over negative 10, which is equals 5.2 seconds. Okay, so let's go to the last one. Calculate the height of a cliff if it takes 2.35 seconds for a rock to hit the ground when it's thrown straight up at 8 meters a second. So we're doing something like this. So the total time I'm assuming it's going to hit the ground below the cliff. I should have drawn a picture. Okay, so I'm looking for this distance here, delta x. It's going to be a negative answer. That's the height, delta x. Actually, delta y. It takes 2.35 seconds for a rock to hit the ground, so the total time 2.35 seconds. Okay, VO is positive 8 meters per second. It's thrown upwards. How long would it take to reach the ground if it's thrown straight down with the same speed? Well, first of all, I have to find what delta x is. Okay, so delta x, so I can use that for the second part of the problem. Okay, so how can we do that? I know A is negative 10. VF is not 0. I don't know what VF is. So because I got time, I can use delta x equals VOT plus AT squared over 2. So this would be 8 times 2.35 seconds plus negative 10 times 2.35 squared over 2. And I get negative 8.81 meters. That's this distance right here, and it should be negative because it's coming from here to the finish. That's a negative down, negative direction. Okay, now what I'm going to do is use that delta x. So I'm going to throw it down with the same speed instead of throwing it up. I already know the answer is going to be okay, it doesn't matter. So now VO2 this is the second part. VO is going to be negative 8 meters per second. All the rest is going to be the same. Delta x is still negative 8.81. A is negative 10, even though he threw it down. After it left his hand, there was no other force acting on it. And that's all I need. Wait. Oh, I'm looking for the time. So, I don't know what VFX is. I don't know what VF is. Yeah, this looks like I'm going to have to use the quadratic formula. So, delta x equals VOT plus AT squared over 2. Delta x is negative 8.81 equals VOT negative 8 times t plus negative 10 over 2 times t squared. So let's put this in quadratic form. So this is -5, -8, -8.81. So ax squared plus bx plus c equals 0. So putting this in terms, this would be -5t squared. The x is the t. So -5t squared minus 8t plus 8.81 equals 0. So I just put this in the quadratic form. So a equals -5, b equals -8, and c is 8.81. I'm going to use -b plus or minus square root b squared minus 4ac over 2a. But you know what? I'm going to be the lazy guy and use my calculator. So, okay, so I get on my calculator, I get two answers. I get -2.345. Obviously, that's going to be the wrong one because it's negative. Time can't be negative. I'm getting a positive 0.749. Of course, I picked up the positive answer. So t equals 0.75 seconds. Okay? So that is the end of this unit. There'll be concepts as well. But the concepts are just cautionary things you do when you're solving these problems. Okay? So that's it. Take care.